Hello, I'm Luke Somerset, team lead of Group LARK. I am joined by Alex, Raul, and Karen to describe the system we designed and the journey that led to our final vision. One of our ideas was a database for a private collection of various types of items. Mike, our client, possesses many unique pieces of history, in addition to books and other materials. He is a well-organized person, but his collection is, as of yet, not documented together in one place. As for what set Mike apart, he is retired and has plenty of time to collaborate with our group. This is in contrast to Matt, another potential client, who is always quite busy running a school and managing a family of 6. The other idea, a charity computer system, would have required wading through quite a lot of red tape, even for a hypothetical project. Ease of communication was our team's deciding factor.
Hello, my name is Alexander Ochotrena. I'm the project manager for the group LARK, and these are all the slides I made. Starting with the project selection, which was a book information system. We picked up Luke's stepfather as the client. The reasons why is he was available, which is one of the main reasons why we chose him from the other options we had. His project included all the requirements, and his stepfather was available to talk and discuss the project with us, which was super helpful when we needed to ask questions and such. The project included making a book database for Luke's stepfather. Um, his father has a book collection and other things, and the database will allow him to search through his entire collection and make it easy for him. This will include a simple system to add a book and remove one, a little bit more complex than that, but that's the basics.
Our problem definition outlines the nature of Mike's collection and how it ought to be organized. The collection is varied, meaning a database will need to accept different kinds of item records with different data fields. In addition, the database must be able to search and sort the collection based on these different data fields. Item records within the database must be able to store various kinds of files as data, such as text, audio, video, etc. In our scope of work, we decided together with the client what specific functions the program must accomplish. In addition to creating a thorough database for the collection, the client also desired the ability to back up the database to the cloud and work from the cloud directly. In addition to a local app, a web app was conceived, which would be accessible on any device with an internet browser. Even if no user is signed in, someone accessing the website may view a portion of the collection flagged for public viewing.
Hello, my name is Raul. I'm from Group 1, and this is the feasibility analysis. The cost-benefit analysis is people, including IT, staff, and users. A basic IT support role might cost around $40,000 to $60,000 annually. Hardware and equipment, a basic server might cost around $1,000 to $3,000. Network equipment might include routers, switches, and cabling, and what will cost a few $100s to around $1,000. A backup system is essential to protect your collection data. Backup solutions can range from a few $100s to over $1,000. Formal and informal training, including peer-to-peer support, budgeting around $1,000 to $5,000 for staff training is a reasonable estimate. Licenses and fees, $500 to $5,000 or more, depending on the software features and choices. And the benefits are increased efficiency, improved visitor experience. Software enhances the visitor experience, increases revenue. Cost reductions, cost savings in areas such as reduced paper use, energy efficiency, and reduced staff requirements. Inventory control. Software can help catalog and manage the client's collection and efficiently, making it easier to track and locate artifacts. Digitization offers a secure means of digitizing valuable artifacts, reducing the risk of physical damage. Disaster recovery protects data and information in the event of disasters, ensuring data continuity. Accessibility enables easy access to collection information for researchers and staff. The project benefits of the system outweigh the estimated cost, considering the total cost of its ownership. Continuation, the organization has staff with the necessary technical expertise to lead and participate in the project. Management does support, which is essential for project success. The client does support the project, and their input is valuable to ensure that the software meets their needs. Technical, during the development process of this project, our team has the necessary hardware, software, and network resources. Our team has the experience and skills to complete this project successfully.
Next, we have the work breakdown structure, the WBS. This defined what we did every week and what deadlines we had for each week. Starting with the 1.2 project initiation and planning. This is where I made the work breakdown structure, had it done by, let's say, like 10, 12, and turned it in. Next, we had the defining the requirements, the 2.3 traditional models, the 2.4 object-oriented models, and the 3.1 object-oriented models. This was our breakdown structure for the entirety of the class. Next was the PERT chart that we made, the 1.2 project initiation and planning, the problem definition, scope of work, project feasibility, the Gantt chart, PERT chart, then on to the next group video. Then we go into the next section. This is where these are the requirements we had to do, determine system requirements, talk with the client, build or buy, and then have the group video done, and then move on to the next model, have all of the next stuff done, like the event table, context DFD, ER diagram, DFD level 0 through 1, and pseudocode. Have the next group video. This is a shortened version of our PERT chart because it's a little long.
Hello everyone, my name is Karen Villablanca and I'm a team member. And this was our Gantt chart that has guided our progress. It has been a crucial tool in outlining our project timeline and helped us manage tasks. It also helped us stay on track from the initial planning phase to the different stages. The Gantt chart has proved to be very useful in quickly assessing the status of each task, whether it's on schedule, delayed, or completed. This also enabled us to assign tasks to team members and track everyone's progress. Even in instances where deadlines are missed, we were able to catch up and work efficiently and remain on course.
Our prioritized requirements look very similar to our scope of work, just organized with priority. The most basic requirements are listed at the top, such as database functionality. The items get more complex as you go down the list. For example, there will be a sign-in system, and users will have different access and edit permissions depending on their role.
In deliberating the decision between building our own collection management system and opting for an existing solution, we examined Proficio elements and made comparisons. It's a specialized software for managing collections. We then identified its features, advantages, and disadvantages.
The program was made by Rediscovery. It has multiple museum clients and is made for smaller collections, which was perfect for our client. Proficio element features: it had customizable screens, intuitive navigation, button bars and menus, customizable fields, quick pick lists, and it allowed for easy data entry, which was perfect for the client because it didn't need to be that complex for his collection, and it had a high quality search.
Now, these are the advantages of our program over Proficio elements. Our program offers a more inclusive experience by providing standard public and private viewing features, unlike in Proficio elements where such features come at an additional cost. Additionally, our multimedia support surpasses elements, allowing users to attach various files and manipulate media easily. To enhance user experience, our program allows interface customization, including font size, light versus dark modes, and high contrast mode, which are features limited in Proficio elements. We also ensure seamless data management with robust export and backup functionalities supporting different formats. And moreover, our program excels in user control and security, offering unique settings and comprehensive access control.
Determining a build or buy is a better option. So pro elements, advantages elements has over our program. Time saving pre-built software is readily available and can be implemented faster, saving time in the initial setup and configuration. Cost efficiency, buying existing software is often more cost effective than developing a custom solution. Updates and support. Purchase software comes with regular updates, bug fixes, and customer support. This ensures that your collection management system stays up to date and functional. Proficio Element has an initiative interface for efficient data retrieval. Its features such as global searching, sorting, grouping, and filtering of records will help in the quick location of specific information within the collections. Covers various collection management activities, including tracking exhibits and loans. User-friendly and easy to navigate interface and provides easy access to customer support. Our program, high initial cost, custom software development can be expensive with upfront costs for design, development, and testing. Maintenance and support responsible for ongoing maintenance, updates, and support, which can be costly and time consuming. Testing and bug fixing requires extensive testing, debugging to ensure that it functions as intended. This can be time consuming and resource intensive process.
Upon comparison between our database and the commercially available equivalent called Proficio Elements, we came to the conclusion that our product would be better tailored to our clients' specific needs. In addition, support and maintenance would be more personalized with our team. Our event tables are split into 4, describing 3 kinds of users, and 1 system event table. Our first event table is for readers, those who access either the local app or the web app without signing into a user account. Their events are mostly limited to viewing and searching public item records, as well as requesting item record summaries, signing in, and requesting an item to be loaned or donated. The second table is for editors. In addition to the events of the reader table, editors may create, edit, duplicate, or delete item records and other data. They may also sync their local database to the cloud and view recent changes. Administrators may perform the events from the reader and editor tables, but they also have the ability to make a global search and replace event. They may view and edit user accounts, and they may also view requests for item loans or donations. Finally, the system table has a couple automated sync events that may be toggled on in a user's settings. The system also updates a change log as changes occur.
This is our ER diagram. Ephemeral to artifact is many-to-many relationship. An artifact can have various types of ephemera, and an ephemera can be associated with multiple artifacts. Attributes, ephemeral ID, and type. Artifact to inventory is one-to-many relationship. An artifact can be part of an inventory. Inventory tracks multiple artifacts. Attribute to item ID, location, and item name. Artifact to books or magazines is many-to-many relationship. An artifact can have various publications. A publication can be associated with multiple artifacts. Attributes is publication date, author, title, publication ID. Artifact to technical manuals or documents is many-to-many relationship. An artifact can have various technical documents. Document can be associated with multiple artifacts. Attributes are document ID, title, author, and date published. Artifact to video audio recordings is many-to-many relationship. An artifact can have various video and audio recordings. A recording can be associated with multiple artifacts. Attributes is recording ID and title. Artifact to iconic sculptures is one-to-one relationship. An artifact can be iconic sculpture, and iconic sculpture is associated with one artifact. Attributes name and sculpture ID. Login to inventory is one-to-many relationship. A user login can be associated with multiple inventory records. An inventory record is associated with one login. Attributes are username, password, and email.
Next is our context diagram, which provides a bird's eye view of our system. It illustrates interactions with external entities. This diagram helps us understand the system's boundaries and the flow of information between different components. In this diagram, the collection management system is the central part of our setup, overseeing collection organization and maintenance. Curators, the main users, handle tasks like adding and managing items, attaching files, and creating reports. The web-based app acts as the interface for users, enabling viewing, searching, and accessing collection data for different user types such as the public, researchers, and museums, each with varying levels of access. Then this is our level 0 diagram that has the functionalities and interactions within our collection management system. And I will just summarize its interaction here. The curator manages the database by providing collection-related data and uploading images and multimedia files. The database in turn serves as the source of collection data for users, with the web app accessing and interacting with it. Users, including the public, access collection information through the web app, and they can request quick reports which are generated and provided to creators. Additionally, external data sources contribute additional information and data to be managed in the database.
Here we have the level 1 DFD, starting at the search, which went out from the artifacts, the books, the videos, went to the data storage. We have the user interface, the public user login, the web app. You have login error. The user will then try again. From the user interface, they can have a review. They can put the review input. If it's an invalid review, it goes back to the review page. If it's valid, then it goes into the data storage. This was the pseudocode that we had for the level 1 DFD. The user login function, it would have an input of the user's email and password, validate the information is correct, otherwise a while loop as the information is incorrect, show wrong information, have them log in again. We'll have the search function, input, user search inquiry. This will then look through the database to find the results, then showing a display of artifacts, books, and videos. Next we have the user review function. I'll take the input of the person, see that the review is valid. If not, then I'll redirect to the review page. It will show an error. Otherwise, it will store it into the database.
Our use case illustrates the most common cases the program will encounter. Those who view the database, labeled as readers, may access and request information, usually online. The cloud database was synced and updated likely by local apps information. That information was managed and put in place by editors on the opposite side of the box. As with previous diagrams, our system sequence is halved between editors and readers. Information is entered by administrators and editors, updating the local database. The cloud database is synced with the local database, which allows readers to view item records and request item summaries. In the opposite direction, readers may request item loans and donations, which travel through the web database to the local database and becomes viewable by administrators.
This is our class diagram for the museum class. Attributes are museum ID, an identifier for the museum, name of the museum, location of the museum, description of the museum, exhibits, a list of exhibits in the museum. Methods are add exhibit, add a new exhibit to museum, remove an exhibit from the museum. Get exhibits, retrieves all exhibits in the museum. Exhibits in the museum have a one-to-many relationship with the museum, indicating that one museum can have multiple exhibits. Exhibit class attributes are exhibit ID and identifier for the exhibit, title of the exhibit, description of the exhibit, date when the exhibit was created, type of the exhibit, artifact, a list of artifacts in the exhibit. Methods, add artifact, add the new artifact to the exhibit, remove artifact, removes an artifact from the exhibit. Get artifacts or choose all artifacts in the exhibit. Artifacts in the exhibit have one-to-many relationship with the exhibit, indicating that one exhibit can have multiple artifacts. Artifact class attributes, artifact ID and identifier for the artifact name of the artifact. Description of the artifact, day acquired, day when the artifact was acquired, type of artifact. Image, URL to the image of the artifact. Exhibit, the exhibit to which the artifact belongs. Categories associated with the artifact. Tags associated with the artifact. Methods, update description. Get image, get details. Categories and tags have a many-to-many relationship with artifact, indicating that an artifact can belong to multiple categories and have multiple tags. Category class attributes, category ID, an identifier for the category name of the category, artifacts, a list of artifacts in the category. Methods, add artifact, adds an artifact to the category, remove artifact, removes an artifact from the category. Get artifacts, retrieves all artifacts in the category. Artifacts in the category have a many-to-many relationship with the category, indicating that a category can have multiple artifacts, and an artifact can belong to multiple categories. Tag class attributes, tag ID, identifier for the tag, name of the tag, artifacts, and list of artifacts associated with the tag. Methods, add artifact, associates with artifact with the tag. Remove artifact, dissociates an artifact from the tag. Get associated artifacts, retrieves artifacts associated with the tag. Artifacts associated with the tag have a many-to-many relationship with the tag, indicating that a tag can be associated with multiple artifacts and an artifact can have multiple associated tags. User class attributes are user ID, an identifier for the username of the user, password of the user, email address of the user, first name of the user, last name of the user. Museums, a list of museums created by the user. Methods is register, allows a user to register in the system, log in, enables a user to log into their account. Search artifact permits user to search the artifact using keywords. View exhibit displays a list of available exhibits in the museum. View artifact displays detailed information on a specific artifact. Users can add one-to-many relationship with both curated museums and liked exhibits, indicating that user can curate multiple museums and like multiple exhibits.
Next will be our activity diagram, which visually represents the flow of activities within our program. This diagram will provide insights into the sequence of operations and an overview of how users will interact within the system. This will include activity diagrams for each users like the admin, editor, and the reader. This is the activity diagram for the reader. The reader begins by initiating the system and access the collections from the database and review collection information. They can request item reports, and the system generates and displays them if available. After reviewing the report, the reader may request loans or donations, and the request is sent to the admin for processing. If there are no loan requests, the reader returns to viewing collections. The next diagram is for the admin. The admin starts by logging into the system and then gaining access upon authentication. And actions include updating databases, reviewing loan and donation requests, managing collections, and adjusting system settings. The admin notifies readers or requesters of declined requests, and if accepted, releases the item, notifies the requester, and updates the system with loan status or donation information. And for the editor will initiate by logging into the system, accessing the editor dashboard upon authentication, and from there, they review contributions, select an item for editing, make necessary changes, and save those changes.
Next, we have the state chart diagram, starting at the customer, where you log in an account or create one, or you can be a guest user. Just have the guest user log in. That will lead you to the menu, which will then lead you to the search, which will display the information that you want. You can either add or request for more information. There'll be a menu to submit that information. The admin must approve or deny. If they approve, it'll be added to the database. Otherwise, they'll be sent a denial email. Next was the database schema. This we have the admin and everything that the admin will have, which will be their email and password, the employee ID, their first name, their last name, password. For users, it'll just be their email, first name, last name, password. And then for guest users, they'll just have a default login. For the search, you'll have the user inquiry and the time of search.
And this is our package diagram that has 4 subsystems, which flow starts from the user and data management subsystem. It manages user-related data and has access to the database management subsystem for database-related operations. Database management handles local and cloud databases, synchronizing them together. The database management also exports functionalities or elements to the collection management subsystem. The collection management manages collections of records and artifacts, importing functionalities or elements from the database management subsystem. User interaction subsystem involves the reader class, which uses functionalities from the collection management subsystem to view records and artifacts.
Our user interface prototype is unrefined as to aesthetics, but is intended to show function. The layout of the main screen attempts to allow plenty of room for the database entries while fitting some useful elements to the sides, such as the directory of the database, an item preview image box, and search options. More tools, features, and actions are stored in the menu bar up top. Certain actions will open new windows, which are not pictured. If an item in the list is double-clicked, it will open the entire item record in a new window. The client requested that the information within each row was able to be word-wrapped, so long names or descriptions may still be viewed on the list. This is an app designed for specific use for a small group of people. Training would consist of a designer meeting with the client and any editors he wanted to bring on and demonstrating all uses of the system. Users would be encouraged to try it for themselves and ask questions to get familiar. Then each user would be tested on their understanding by being asked to perform various tasks with the program. Each app would include a manual in the help section, and physical manuals would be distributed as well. The client would have direct contact with at least one member of our group, and may report when maintenance is required or if a bug is found. The program would be updated when necessary, for example, to comply and function with newer operating system versions.
And that's it for our final presentation. Thank you for watching.